Alrighty, today we're going to be taking a look at the Decorator Design Pattern. Unfortunately, this video took me a little bit longer than I'd like, but as you can see, I have 3 different potions. They're all actually the exact same object, different decorations on them. So that one's just a default potion. This one is the second stage of potion, which is just one of the effects, and then this one is 2 different types of effects at once. So you'll see when I throw it, we get our blue effect, and when I go into it, I am actually shrinking. And also, it will say that I am hairy. I'm hairy and I am no longer hairy. So this system will allow us to dynamically create potions with a factory, which we're going to be showing soon, just like this. So the idea is we create a potion, which we instantiate just like we normally would for any object. And then when we create our object, we just initialize the effects, whatever effect that we need. And you can see that we can stack new effects onto it. Now, a disclaimer before we actually begin with implementation, I do not like the decorator pattern. I do not like how many times you have to say new, you create new objects, and I feel like it's not a great way to manage memory. That being said, if you want to adhere to solid principles, yes, this does the job. Everything is super separated. It's very easy to locate where you need to go. So for instance, if I needed to change what the shrinking effect does, then I would go into the shrinking effect class and I would modify that. That being said, let's get into the implementation of this. We're going to have to create a lot of files for this design pattern. To start, in my project, I happen to have already a potion, which is going to act as our main file. So I'm going to pull that up quickly. It doesn't actually matter what you use as long as the concept is clear. So here is the potion file. In the potion file, we break into an effect cloud, which is what gives it the color. But the idea is we have the ability to initialize with some kind of effect. So how the design pattern works is we want to have a base class or interface that is just going to describe the logic for what's going to happen. Then we have 2 implementations. We have our core implementation, which is a mundane or simple effect. You can imagine this like an undecorated pizza or a coffee with nothing in it. So this is an empty potion almost. It just doesn't do anything. Then over here, we have an abstract class. And our abstract class is going to represent what can be decorated. It's going to be like the driver file that'll control all of the different decorations and effects that we can apply to our character. So let's have some effects as well. We're only going to do 2 in our example, and ones that we can actually see, ideally. We can make one that's like a TP, teleport, just for funsies. I don't know, why not? Maybe it just like teleports you 100 meters in the air. Maybe it flings you. I don't know. We can make one that is... It doesn't truthfully matter. Let's just reuse shrinking because that's another one that we can tangibly see. And then again, we can do hairy. It actually does not matter. The abstract driver is kind of what's going to get everything working, and this will be called our potion decorator or effect decorator. Now the idea is the system should be extensible enough that it doesn't just apply to potions, but I can put it in any effect that I need made. And yes, you could break this down further. You could say that a potion is, or a potion decorator rather, has an effect and then have that as a different object entirely, and then have a whole nother tree for an effect decorator, or it really depends on what you're trying to get at. One of the downsides to my implementation is that in the effect handler, which is what's actually controlling the effects, there is no way for me to actually be able to tell what effect I'm executing, which is great for encapsulation. But it means that if they have the poison status effect, and I add the poison status effect again, there's nothing I can do about that. They just have the poison status effect again. Maybe you want that, maybe you don't. I'm thinking in my game it's acceptable, because if you are applying 5 potions to yourself, it's kind of funny. But yeah. Alright, so let's begin. The first step is we need to create a way to create an object in the first place, and an object that goes with it. So something needs to use it, and then we need a creation piece, right? So let's just do both of those quickly. And I'm going to create a new folder, so that way we can just get everything kept together. So I'm going to create a new folder called Decorator. Now in here, we're going to create a C# script, and this is going to be called our temp factory. And I'm going to call everything temp because I've already done this, but I just want to show you guys how to do it as well. The next one that we need to make is going to be our temp and then potion. Or to be honest, we could probably just reuse potion, but I spelled potion wrong. Awesome. After that, we need to make our interfaces. So back to our drawing, we have to make an interface ItemP effect, right? And then from our interface, we have a default effect. So the basic one, what it should look like by default. So we'll create another script, and it's going to be our default effect. And then we're going to create another one that's going to be called the effect decorator, which I'm going to call temp effect decorator, again, because these things are temporary. And the next thing that we need to do is we just need to implement all of our scripts that belong to our decorator. So if you were decorating like a pizza, this would be literally your toppings. Same idea with coffee. If this was for like a UI window, then it would be your buttons and whatnot. Whoops. But I guess we can create a new folder actually. I can call it decorations. And then in here, let's implement our things. Where did my mouse go? It's just vanished. Okay. We're gonna create a, I don't know, temp, and then let's say teleport potion. So just teleport you randomly. And then let's create a it's kind of hard to implement interesting ones in a short period of time like this, but let's just make a laughing potion. I don't know, maybe it makes you laugh because it's funny. Who knows? You tell me. Alright, we have all of our scripts, give or take. Obviously, we would need to add more of these, but we're going to run into a problem pretty soon. And the way that I came up with a solution might not be something you agree with, but I think it's the best answer given the context. That being said, let's start with our factory and our potion. So I'm going to pull these over and temp factory. It's in an open for some reason. Let me just open it quickly on my other side here. Temp factory, there it is. And let's add these to our namespace. Okay, now our temp potion is going to have an ItemP effect. I have to remember to put temp in front of everything. And then we need a way to initialize our effect. And then we'll bind it. And because the name is the same, we should say this. Obviously, we might want to change this implementation, but this is my preferred way, just that way we can keep our game objects separated from our basic default C# classes. I'm not sure if there's a better way that you could do this without initialize, but this is what made sense to me. Then in our factory, let's just keep start because it doesn't actually matter for now. And in here, we need to have a reference to our temp potion. Just like that. And then we need to create it, of course. So var potion equals, instantiate potion. Let's just do it at our position. There you go. And then we just need to bind our effect. So we're going to create a ItemP effect, my effect, and then equals, and we need to start it as something else. But before we can even bind it to anything, what we really need to be doing is binding our effect. So I'm just going to open some of these other files here. Firstly is the default effect. Now the default effect needs to be able to exist completely on its own. So it's only going to extend the ItemP effect. And it's going to implement our namespace. The temp effect decorator is going to almost be the exact same thing. Again, no start and update because it's not going to be a mono behavior, but it's going to be ItemP effect. And now the big difference here is you can't create one of these. You have to abstract this. And then finally, we have our two decoration objects. And in these decoration objects, we're going to have them be children of our decorator. So temp effect decorator. And then again, temp effect decorator. So what this will allow us to do is we can drive any of the logic we need to through our decorator, and then we're still decorating our core object in the end. And these guys will be able to control the logic individually without us necessarily knowing what they're doing, which we'll go through as well later. So from here, we can now say that our effect is a new default effect. Right? So we're creating our default effect object. And then we can pass it down, our potion type equals, and then, or rather dot, and then initialize my effect. And we can do this for as many things as we want. So the idea by the end of this is we can then say my effect equals new temp laughing potion, and we pass down my effect, so we're adding onto this potion. So we're like creating a stack chain from which it's just going to reach up and grab the next potion or the next effect that it needs to do. So let's start in our ItemP effect, and let's ask ourselves, well, first let's convert it to an interface actually. Just like that. Don't need Unity Engine, at least not yet. And then what we need to do is we need to ask ourselves, what information do we need from this object? For the sake of demo, let's just get a description. So let's have a public string get description. In my version, I did a string builder and I built the string dynamically, but in this case, we're just going to use description because it's easiest. We can also use a int and call it get cost, right? Or maybe we want to say a float and call it get duration. And then if you really wanted to like get into this, you could even create an enum that's called effect type or like operation. And then you could say like addition, subtraction, yeah, just like that. And then what you can do is you can have a public operation, and you can say get duration operation. And what this would mean is we can either multiply onto the duration, or we can divide or subtract, or do whatever we need to do based on how that class sees it should happen. And one of the interesting things about Decorator is the order in which you add stuff can matter. You know, bed mass, order of operations, except it's just always left to right. Like if you were to say 4 plus 2 times 6, if you just said it out loud, then you're going to add 4 plus 2 first and then multiply by 6. Otherwise, you would first multiply 2 by 6 and then add 4. There's the difference. I'm not going to go through the whole step with the operation. I don't want it. It's just not necessary. But we're going to implement the rest of this now. So in our default effect, let's implement our missing members. Okay, and for now we can just say return our description as a default effect and return duration as 0. And this is where we have our first problem. Yeah, you can hard code everything here, and that's totally cool. I really don't like hard coding, and like looking at other people's videos and trying to understand this pattern for myself, hard coding is just what most people do. Now we could implement other design patterns like a service locator to actually get our resources, and I kind of want to do something similar to that. In Unity, we can reload our resources, and thinking about how Minecraft works, they have like this JSON file, massive JSON file that they just read from. I don't think it's terrible, but it definitely has a memory impact if we are to do something like that. But here's what I want to do. In our folder, let's create a new script and let's call it temp and then variant loader. And this is going to be like a singleton, not a true singleton, it's just going to be a static class. So more like a utility file. If it would load, it's just never going to load, it's fine. Where is it? There it is. Oh, it opened. Okay, fine. So what we want to do, again, remove start and update, remove model behavior, and then we want to make this a static class. And then we need to be able to load our resources, but we want to store them in a map so that way we can access them easily. So I'm going to create a private dictionary. Everything in here needs to be static because we're a static class. Store by string, and then we need a scriptable object as well. So hold on, let's go back. And let's actually use the template for this in Unity 6. So if I go to scripting and then scriptable objects, there's the template. And then I can say temp effect stats. And now I can record all the stats. And this makes it really easy for the designers to get things right instead of just hard coding things like a total bot. Dude, where is it? Oh, here it is. Okay. So we have our file. And you can see we have a way to create more of these as well. And what we're going to do really quick is just define what we want. So we have a description, and we can also put this inside of a text area. So let's actually mark it as field, serialized field, and let's put it in a text area. And then let's have a get and private set. So that way no one else can modify this except for us. Let's duplicate this and have a color that's going to be called get effect color. Oh boy. Get effect color. And then in here, this is going to be a color usage, and we're going to say true, true. And what this means is, as you can see, we're showing the alpha and the HDR, which is how bright or luminous our object is. So it just makes it really flexible, and it's a really nice way to work in Unity rather than just guessing. So if I come back here, I can now say we have a dictionary of temp variant loaders. I can call it, oh, sorry, wrong file, temp effect stats. And then we can call it stats equals, there it is. And then I can make my function private static, and then we're going to say temp effect stats get stats based on a name. And then we're going to first check to see if it exists. So I'm going to say if stats dot try get value of name out, and then we want to return our S for stats, I guess. I don't know, I'm lazy. And then we're going to return S. So if we find our object, return S. But if we fail to find our object, then we need to say stats.add name. And we're not going to create a new stats, but instead what we want to do is we want to load it from our resources. So what I've effectively done here is some lazy loading. Resources.load, and we want to reload by its name. Maybe we have a special folder for it. But that's the idea. We need to mark it as a type, and it's going to be a temp effect stats, so it loads correctly. Now, resources.load, if you don't know, is very expensive, and you want to avoid it, which again is not why I like the pattern so much, but we kind of just have to live with it. Anyways, once we've loaded the object, let's store a reference to it as well. So var x equals, and then I'm so goddamn lazy, it's unreal. And then finally, we can return our object just like that. So now we have our loader, and this is lazy loading, but you can also have it be automatically loading, so that way the strain is on your level. The advantage to lazy loading is you're using less memory until you need it, and the advantage to just loading them all in is you're not going to have lag spikes. So pick or choose, it's up to you. Anyways, in here, when we create our, let's start by going to our default effect here. Instead of just loading our effect, what we can do is we can have, I guess for this one it's probably fine. It truthfully does not matter a whole lot. Also, I'm seeing now that it's not a color that we want, but rather a duration, so I'm a bit of a clown. Let me go back quickly to this. We're not going to do color usage because it doesn't make sense, but we're going to say min 0 because you can't have, I guess you could have a negative time if you want to subtract, so we're not going to say anything. We're just going to say float duration. Just like that. Alright, so now back in our temp effect decorator, we need to implement our members, and then with our members created, what we need to do is create a constructor. So firstly, we need a reference to ourselves. So this is going to look a little bit weird, but a private read-only, and then it's going to be ItemP effect effect. Then we need a constructor, so a public temp effect decorator. where we construct our effect, and then we need to bind our old effect instance, which I'm going to mark with an underscore. Effect is our effect. Now, in the default implementation of this, you would literally say return and then whatever you want plus your effect at getDescription. And this is your decorator pattern right here, is every time you're adding something new to the stack and they are pushing whatever they need to say onto that. So every single object that you've added will now say their own piece, which I hate because now you have 1,000 pointers and every object knows about each other. But it's neat. It's neat. I'll give it that. So if we continue with this, I don't want to do it like this every time because firstly, if you're working with strings, you have an additional memory cost here, but we can bake it, right? Like why have this up call every single time? The only advantage to having an up call would be if you needed to for some reason retrieve something from here. In our instance, we don't. So what I'm going to do is I'm going to create some more variables, a private read-only string that's called description, and a private read-only float that's called duration. And then instead of returning anything else, I'm just going to return my description and my duration. So I'm just going to remember them. And the downside of this is I have an increased memory cost. But I expect that these objects will be short-lived, but they could be viewed multiple times, especially getDuration would be viewed multiple times, so we can resolve this cost. Now, truth be told, I don't know if this is actually better than doing something else, but in my opinion, this is the most clear answer, especially because the objects will be garbage collected, and there should only be one remaining by the end, I believe. No, they won't. They all have reference to each other. But if we said description and then is equal to, and then whatever our description is. So firstly, we need to actually load ourselves in. So we're going to say temp variant loader, get stats, and then we need to plug in our self, which will be custom. And let's create an abstract getter for this. So I'm going to say public abstract string get effect name. Right, and this will be purely for actually retrieving the value, and let's just plug that into here. Okay, and then because we're abstract, again, we're allowed to mark things as abstract, we can just assume that it's going to exist. We need to store the reference, so temp effect stats, and then over here now we can say stats.description, and then let's append onto it our effect, or actually let's not do it like that, but we're going to say effect.getDescription plus, and then we're going to do a new line and a star and then a space. And again, you can see the memory cost with these underscores, so we do need to be cautious of this. And using a string builder could be really nice for just reducing that one-time memory cost, but doing it like this, it's only a one-time memory cost anyways. Anyways, we also have our duration where we can get our effect duration just like that, but let's also add in our actual effect duration ourselves just like that. And this is also that pattern, but now we have the ability to use scriptable objects, which we didn't natively have before. If we need to, we can remember our effects, which I've already done. I don't know why I'm doing it again. But in our instance, we actually don't necessarily need it. So I'm going to remove this from here and like that. Because we're baking our data, we're going to remember what's happening anyways. Next, we can do our potions, this one and this one. Okay, and then you see we need to implement our effects. We can leave the constructors blank. They just need to say that they know what their constructor is doing and they're upcalling. But for their effect names, this one's going to look for a laughing potion. And this one is going to look for a teleporting potion. We need to be careful to actually implement these names perfectly later or we're going to have problems. Alright, the next thing that we need to do is we need a way to be able to actually access all of this. And I can just showcase really quick what I did in mine. So if I head over to my IEffect, just because ours is going to look a little bit different, I have all of these functions as well. And then I also have an onAdded function. And if I go to my effect decorator, the onAdded function, this is what I meant by it's a driver, or it can be a driver class. When we add it, this is the public implementation that anyone can access. But then when we have our other classes, we want them to be able to do it, we have this virtual pass down that they can override in order to declare that we do this. And if they do override it, then it's going to automatically tell our advisor or our player what's happening. And in this case, you see I do need to remember who our parent is, because we need to ask them for what they're doing as well. But in this case, we don't need to ask them for what they're doing. Now, I could even modify this logic and just move this straight into here. And it should work the same, I believe, because we're just upcalling every single time. And then the onApplied effect is just overridden, and it's going to do whatever it needs to do. So, for example, in the Harry effect, it'll do its thing. And by default, it's blank, and it doesn't need to do anything. So if you wanted to leave all of these blank or make them abstract, it would be totally up to you. So I'm going to put these back away. And all we would need to do so these are actually, they already work, because this is not a very complex demonstration. If we wanted them to behave differently, then we need to add a bit more effort. But in this instance, everything should work. The only thing we're not loading is this, which is hard-coded. In my opinion, it's not the end of the world. Anyways, we can now create our effect. We don't actually need to load our potion now that I think about it, so let's just comment this out. But let's create our effect, and we're just going to do 3 debug logs. So we're going to say debug.log, and then a plus myEffect.getDescription plus, and then let's have our plus again, myEffect.getDuration. Okay, we're going to run this 3 times, where we have A, B, and C, and in this effect, and then over here as well, and we're going to add a temp and then teleport potion. Now we do need to be cautious using this as well. It is possible to just continuously add laughing effects if that's what we wanted to do, but that is roughly it. Now this video is getting rather long, so let's just get to the end here. If I head back over to Unity, should I have the game open? Uh-oh. We're going to create just an empty object and attach our thing to that. So I'm just going to say that this is our temp factory right over here. We don't actually need a potion. We've disabled that logic, but what we do need to do is in the resources folder, we need to create these effects. So if I go to scriptable objects, it's one of them, temp effect stats, there it is. And then we need our laughing potion. And another cool thing that we can do is if we have another system to intercept the description and then change the text, so it's works with TextMesh Pro. You can change images and stuff, make things glow or make them wormy. TextMesh Pro is awesome. But we have laughing potion, and we just need to make sure that our spelling is correct or this isn't going to work. So if I go back to laughing potion, see that's the name. And we also need teleport potion is the second one, like that. And then haha. And then teleport is, you are now here. Sure. And then teleport potion is going to have a duration of -5, and laughing potion is going to have a duration of 20. Cool. I can't remember the order that I added them. It's not like it matters, but if I go to console now, we should hopefully be able to see them all in action. Let's enable our, disable the search. And as you can see, we have our effects here. And you can see that the C effect here, C default effect, has all 3. Haha, and then you are now here, and it's saying that there is 15 seconds. And then haha is saying there are 20 seconds. And notice how it's at the end. That's because of our string, the way we built it. We did these, what are they called, new lines, which is why you're going to see that number at the end. And then our default effect just has a default effect, 0. And you'll notice they all say a default effect. Right, so you might want to say mundane potion. But that is the idea behind Decorator. We've now created this dynamic way where we can hide or encapsulate what we're doing. And if we ever needed to change what an effect is doing, then we can simply just go to that effect script and modify one of its functions. And that's it. And if we need to create a new effect, we just override effect Decorator and make sure we fill in our properties correctly. That's all. Take care, guys.